All right, so we can also use the normal table and the calculator to go in the other direction. So again, I'm going to draw pictures to show you what this looks like. So if we have a percentile, we can find the z-score that would be associated with. So the first question, or first example here says the lowest 10%. So you're drawing same pieces that you're going to keep, right? We still want to put the curve, our mean of 0. And then normally we want some sort of cutoff and a shading, right? And so here is where we pay attention to where this percent is. So if we're talking about the lowest 10%, we're going to start on the left side, and we're going to shade what looks like 10% of the curve. So now we have the probability, we have the area, but we don't have what the corresponding z-score is. We do know some things about this z-score right before we even get started. We know the z-score is going to be negative because it's below 0. We also know, if we think back to our empirical rule, that this z-score is going to be about 1 point something, right? We are more than 1 but less than 2 standard deviations, so we're like negative 1 point something for that z-score. So if we want to use the table, let's go back to that table really quick. That's not what we want at all. There, table. We know we need a negative z-score. As we said, we know it's around 1 point something, negative 1 point something. But what we're doing now is we know this and we want to find the z. So we're going to start in the middle and we're going to be looking for that 10%. And the 10% is a left side, so that's exactly how we're going to use it. So I'm going to search around the table for the closest thing I can find to 10%. So here's the next closest, but that is not as close. This is only off in the 10,000ths place. And then we're going to go back out to figure out exactly what that z-score was that would have given it to us. So negative 1.28. Let's go ahead and enter that value. So our z here would be a negative 1.28. Now, the only thing that changes with the other two is that we need to be clever. Remember, our table is giving us left side probabilities. So when we see something like the highest 30%, now we're shading till we get about 30% of the curve on the high side, right? So now we're shading a little bit more. We want to know exactly what that is. We know this is 30%. If we search the table for 0.3, we're going to get out a negative z-score. We're going to get the z-score on this side, which is fine. We can just make it positive knowing that it's symmetric. Or we can be clever. If 30% is on the right-hand side, that means 70% is on the left. So we could be searching the middle of the table. In this case, we'd search the middle for 0.7. Now here's where I really dislike the table. This searching thing is super annoying to me. So I'm going to give us the calculator shortcut, and we're just going to use that from here on out. So in this case, we're doing the opposite of normal CDF. So this calculator shortcut is called inverse norm. And inverse norm takes the left side probability, or left side area, just like our table, and then your mean and your standard deviation. So for this one, first one, we just plug in 0.1, 0 and 1 if we wanted to. For the second one, we do inverse norm of 0.7. And if you don't have the wizard, remember, if you don't give it a mean and a standard deviation, it defaults to giving you out a standard normal, so a z-score. So again, we're still in the distribution menu. And you can see inverse norm is right below normal CDF, 0.7. And if you don't give it a mean and standard deviation, it's going to give us just out that z-score of 0.5244. Now, z-scores are the one time in this class that I'm really okay with you rounding to 2 decimal places, because if you were to use the table, the best you can do is 2 decimal places. So if you keep 4, that's great. If you keep 2, that's also okay, but this is the only time that's really allowed. All right, and so the last one here, I want you guys to think about what you're going to be typing into calculator, what you're going to be searching the table for. So take a moment, pause the video, see if you could handle the last one. All right, so middle 70. Now we're going to shade from the middle instead of the right or left. And we're going to shade what we think is about 20 or 70% of the curve, right? And here's the weird thing about this one. We're going to end up with two different z-scores that truncate that middle 70. Just like our IQR is the middle 50, and it's bounded between Q3 and Q1. So if we do this, we're going to have two different z's, a z1, I'll call this one z1, this one z2. We know that we're talking about 70% being in the middle. And since the whole area under the curve is 100%, that means we've got 30% in both of these tails. But since it's symmetric, we could actually break up that 30% evenly, and we have 15% in either tail. So if we're going to calculate this in the calculator, oops, z1 is going to be equal to, of course, we're still using, oops, get out of here. We're still using inverse norm. And our left side area, well, that's 0.15. And if we wanted to, we can tell it the mean and standard deviation, right? Mu, standard deviation for that z-score. And then z2, the second one, well, we're still going to have this 15%, right? But we're also going to have this middle, which we know is 70. So the area to the right or to the left of z2, the second z-score, is going to be 0.85, still with a mean of 0 and a standard deviation of 1. You could also have done this as 1 minus 15%, whichever one makes more sense to you. And here's the beautiful thing about this. If we do inverse norm, it's in the distribution menu. 0.15, I'll even put in the 0, 1, even though I don't need to. We get out negative 1.04. Oops. I'm going to round this one to 2. And if we were to do this again and bring it back and do this for the z2, we get the same thing but positive. So technically, if we're clever about this, we don't need to do both because we realize it's symmetric and we're going to have a plus and a minus.